Okay, we're going to look at 9.3 angles of elevation and depression. Elevation makes me think of an elevator, and an elevator makes me think of going up. And so we're looking at going from the bottom or from a base going up. And depression is makes me think about going down. So I'm looking at maybe looking forward and looking down is what we call an angle of depression. If we're given two horizontal lines, these horizontal lines are going to be parallel to each other. And then we have this line of sight here, which is a transversal. And so they make an angle of depression So think about being in the hot air balloon and looking down. And so when we're going forward and then we look down, we have this angle here of depression. And then alternately, if we are on the ground, so we're the person and we're looking up at the hot air balloon, this creates an angle of elevation. And because we have two parallel lines cut by a transversal, these create alternate interior angles, and we know that alternate interior angles are congruent. So our angle of depression, or the measure of the angle of depression, would equal the measure of the angle of elevation. Let's look at example 2 here. Example 2 says a surveyor stands 200 feet from a building to measure its height with a 5-foot tall theodolite. Theodolite is just an instrument that you look through that measures an angle. The angle of elevation to the top of the building is 35 degrees. How tall is the building? So that's what we want to know. We want to know the actual height of the building here, from the base to the very top. We want to know that value. We're given that the surveyor is standing 200 feet from the base of the building. So this is the base of the building, and our person is right here. That's going to be 200 feet. And because this is a right angle, this is also a right angle. So the base of our triangle here is also 200 feet. It says he's going to measure the height of the building with a 5-foot tall theodolite. So our instrument of measurement is 5 feet off the ground when he measures. Okay? So we have to take that into consideration. And then the angle of elevation, so we have our green triangle, and it's a right triangle. And that angle of elevation from where he's at the theodolite looking forward and going up, that angle of elevation is 35 degrees. We want to know then, using the right triangle, what's the height from the theodolite up to the top of the building. So we're going to find just the height of the triangle. When we get done and we find the height of the triangle, we're going to add the height of the theodolite to get the height of the entire building, which is going to be x plus 5. So we have our right triangle. I'm going to draw another one over on the side. It's 35 degrees. We want to know the height, and we have the base is 200. Well, compared to our angle, we have an opposite side and we have an adjacent side. And if I think about my trig functions, tangent and sine and cosine, tangent is the one that uses the opposite and adjacent side. So I'm going to set up that function. tangent of 35 degrees is equal to my opposite side over my adjacent side, which is 200. So to find x is going to be 200 times the tangent of 35, which is equal to I'm using my calculator. You do want to make sure that if you're using your modes in degrees, and so that tells me that x is approximately, so it's not exact, but it's approximately 140 feet. Now that's just x. I want the height of the building, which tells me that I have to take x plus 5 feet. So I'm going to take 140 feet plus 5 feet, which is 145 feet, and that's the height of my building. Okay, let's take a look at example 3. An airplane is flying at 3,500 feet above the ground, and it begins a 2-degree descent to land at an airport. How many miles from the airport is the airplane when it starts its descent? So you can kind of see our right triangle here. See if I can get a little bit better right triangle. There's our right triangle. And it tells us that the airplane is flying 3,500 feet above the ground. So that's the height of our right triangle. And it's descent. So it's descending, it's going down. That's our angle of depression is 2 degrees. How many miles from the airport is the airplane when it starts its descent? So we want to know the distance from the airport to the airplane. That's our hypotenuse. I'm going to put an x there. There's a couple of ways to do this problem. I do know that I can look at this as 2 parallel lines cut by a transversal. So if this angle is 2 degrees, then this angle is also 2 degrees. And so I'm going to draw my triangle. This is 2 degrees. I have a right triangle whose height is 3,500 feet. And the hypotenuse, which is the thing that I want to find, is x. So I have the opposite side, and I have the hypotenuse and my angle. Opposite and the hypotenuse is sine. So sine of 2 degrees is the opposite side, which is 3,500 over the hypotenuse of x. I'm going to use my little trick here, the little 1 under sine, and find the reciprocal. So that's 1 over sine of 2 degrees is equal to x over 3,500. I'm going to multiply both sides by 3,500. And I end up with x equals 3,500 over the sine of 2 degrees. And I'm going to put that exactly in my calculator. 3,500 divided by the sine of 2 degrees. And I get approximately 100,288 feet. So that is the distance from the airport to the airplane. For your homework, you're going to do the practice for 9.3 And you're also gonna do the enrichment. The enrichment, just follow along step by step, and it's gonna tell you exactly what to do. So 9.3 and the practice and enrichment. See you next week.